Alright, welcome to part 1 of the exam pack videos for the June exam. These are the type of questions you can expect in your June exam. Alright, so let's get started with the first. So they give me the diagram and they say, in the diagram below we have point P, which is 7, 4, Q, which is 6, 6, R, which is 0, 3, and then we have point S, which is 3K. So that means the values at this moment of S is unknown. Alright, so in question 1, it's quite an easy question. They're asking us to determine the gradient of RQ. Alright, so the first thing you always do is you write down your formula. So the gradient we know is small letter m, and then it's my y2 minus my y1 value over my x2 value minus my x1 value. Now we go and see, so we want the coordinates of R and we want the coordinates of Q. So R was the point 0, 3 and Q is the point 6, 6. Right, now all you do is you substitute these values into your formula. So let's make this my x1 value and y1 value, and this my x2 value and my y2 value. That means I'm going to put in 6 minus 3 over 6 minus 0. So this will give me 3 over 6, which is the same as 1 over 2. And there you have it. Easy 2 or 3 marks. Alright, let's move on to question 2. So in question 2, they say determine the numerical value. So the word numerical value, or in Afrikaans numerische waarde, means I want a number. So at the moment I have a letter K, but I want to know what is the actual number that should be there. Alright, then they give me further information telling me if S is the point 1K and RQ is parallel to SP. Alright, so that means RQ, this line, is parallel to SP. Alright, so whenever you hear the words parallel or perpendicular being used, alright, your automatic thought has to be, oh, I have to do something with my gradients. Alright, so wanneer ook al vra vir jou sê twee sye is parallel, of hulle sê vir jou twee lyne is loodreg op mekaar, moet jy dadelik weet ek moet iets gaan doen met my gradient. Alright, so now the fact that these two lines are parallel, it means that the gradient of RQ will be equal to the gradient of SP. Now we already calculated the gradient of RQ and we got it as a half. So we know the gradient of SP will also be a half. Alright, so let's go and calculate this gradient. So I know the gradient of SP will be y2 minus y1 over x2 minus x1. So we're going to get the coordinates of S and the coordinates of P. So the coordinates of S is 1K and the coordinates of P is 7, 4. Alright, now we already know that my gradient value is a half, so we can put that in, and now we can substitute in our y and x values. So let's make this my x1, y1, x2, y2. So I will have 4 minus k at the top, and at the bottom I will have 7 minus 1. Alright, so this will give me a half equals to 4 minus k over 6. Now if I want to get this alone, I want to get my k alone, so I have to take everything else over. So I'm going to take over the 6, it becomes multiplied by 6, and a half times 6 will be 3. Then I have 4 minus k. Then I'm going to take over my 4, it becomes 3 minus 4, which is minus 1. And then I'm going to divide on both sides with negative 1. So k actually has a value of 1. Meaning that my S coordinate is the point 1, 1. Alright, and going back to my sketch, I can see that, that actually makes sense if that is the point 1, 1. Alright, so whenever they give you a question like this, where you know your two sides are parallel, wanneer weet jy twee sy is evenwydig, you know that your two gradients are equal to one another. Alright, then you just take the gradient that is part of your unknown value, so it was part of SP, and I'm going to substitute everything in, and then calculate K by making use of equations. Alright, let's move on to question 3. So in question 3, they say determine the coordinates of the midpoint, alright, M of RP. Now automatically your mind has to go, midpoint, middle point. It is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Alright, you need to know your formulas. Okay, so we want to work out the midpoint of RP. So we're going to get the coordinates of R and the coordinates of P. Okay, so my coordinates of R is 0, 3. And my coordinates of R of P is 7, 4. Alright, so now all we're going to do is we substitute it in. So let's say this is once again x1, y1, x2, y2. So I will have x1, which is 0, plus x2, which is 7, divided by 2. And then y1, which is 3, plus y2, which is 4. And if I get that, it gives me 7 over 2, 7 over 2. Alright, this one is also quite easy. Alright, then at question 4, they are asking us to determine the midpoint again of a diagonal QS. Now remember, a diagonal is just your line running from the one angle to the other angle. So the diagonal of your hoeklyn van QS, so here's Q, here's S, so my diagonal will be the line here. Alright, so now I'm just going to work out the midpoint between Q and S, so somewhere there. Alright, so let's quickly write down. So the midpoint formula is M is equal to x1 plus x2 over 2 divided by 1, 1 plus y2 over 2. Alright, so we're going to work out the midpoint of Q and S. So we need the coordinates of Q, and the coordinate of Q is 0, 0, 6, 6, and the coordinate of S is 1, 1. So it is 6, 6, and 1, 1. Alright, so let's say this is my x1, y1, x2, y2. So if we substitute that in, it will be 6 plus 1 over 2 divided by, and I also have 6 plus 1 for my y values divided by 2. So this will give me a midpoint of 7, 2, 7, 2. Alright, interesting thing to note is this midpoint and this midpoint of RP, which will be also somewhere here, is exactly the same. Alright, so in the last question they ask us, what type of quadrilateral is PQRS, or wat se tipe vierhoek is it? So the fact that I can see that my midpoint, okay, so the midpoint of QS is equal to the midpoint of RP. Okay, we already calculated that. Means that if these two have exactly the same midpoint, so let's quickly go back to the sketch. So both of them have exactly the same midpoint there. It means that this line has to be equal to that line. And this line has to be equal to that line. Alright, so we know that this shape here is a parallelogram. Alright, so you can say it's a parallelogram because, and your reason would be, your diagonals bisect each other. Or in Afrikaans, you will also say, sal jy ook sê dis 'n parallelogram en jou rede is hoe kleiner halveer mekaar. So when a question asks you what type of quadrilateral do you have, wat 'n tipe vierhoek het jy, you always look at what did you calculate previously. So we calculated the gradient, which helped, alright, and we also calculated the midpoint. And we saw something interesting with my midpoint, so that is what I'm going to use. But sometimes you'll get something where you can see your opposite sides have the same distance, meaning they are the same length, or you can see that your opposite sides are parallel. So that is what you have to do in your last question. So it will usually be an interpretation question of what you worked out previously. Alright, that's the end for part 1. So come back for part 2 for another analytical geometry type of question you can expect.